Hello everyone, welcome to today's math class. Today we have a good and sweet math Olympiad question before us here. The question is 7 to the power of x equal to 11 to the power of x plus the square root of 77 to the power of x minus 121 to the power of x. What then is the possible value or values of x that will satisfy these equation? So if you're new here, this is Math Prowess. If you've not subscribed, subscribe. Because here we bring out new videos every day for your learning. Okay, so let's take our solution and forge ahead. So we take our solution. Good. Now look at this question here. Here we have a radical. This side we don't have a radical. So let's move this quantity to this side and leave this radical alone on the right hand side. So this is going to give us our 7 to the power of x minus 11 to the power of x equal to the square root of 77 to the power of x minus 121 to the power of x. Now we discover that the radical is now standing on its own. We have to eliminate this radical. How do we do that? We just have to raise both sides to 2. We equally do that to this side also. So this and this will leave. So we now have our bracket open 7 to the power of x and minus 11 to the power of x or to the power of 2. This is equal to 77 to the power of x minus 121 to the power of x. Easy, right? Good. So what do we do next here now? If you watch carefully, we can bring out 7 from here and we can bring out 11 from here. Same thing we have on this side. So let's go ahead and do that. So we're going to have here 7 to the power of 7x rather minus 11 to the power of x close bracket or to the power of 2. This is equal to 7 to the power of x times 11 or to the power of x. Then minus, here we have 11 to the power of x times 11 to the power of x, because 11 times 11 will give us 121. We discovered that 11 to the power of x is common here and it's also here. So let's break it out from this 16 here. So this is going to give us bracket 7 to the power of x minus 11 to the power of x or to the power of 2 is equal to 11 to the power of x bracket our 7 to the power of x, because that is what will be left here if we use this to divide this. When we use this to divide this, then we're left with our 11 to the power of x close bracket. Easy. So let's watch carefully here now. Now, you discover that what we have here is same thing we have in here. So we could use this to divide both sides of the equation. But if we do that, we're going to come up with just one root. But with what we have here now, we have to solve for 2 roots, minimum of 2 roots. Okay, so to avoid losing one of the roots, then we're going to do a simple substitution here. We're going to represent this quantity here with an alphabet, because what we have here is same thing we have here. So at this point we say let, this time let's use p. Let p be equal to 7 to the power of x minus 11 to the power of x. So wherever we see 7 to the power of x minus 11 to the power of x, let's put in p there. So this now implies that our p to the power of 2 equal to 11 to the power of x p. This is easy. Move this to the side of the equation. So this will now give us p to the power of 2 and minus 11 to the power of x there times our p equal to 0 here. So what do we do now? P is common here, P is common here, so let's factor out P. So this is going to give us our P bracket P minus 11 to the power of x close bracket equal to 0. Remember what is called the zero product rule? It says that if you have your A times B equal to 0, this will give us A equal to 0 or B equal to 0. So if we subtract to this, we can apply that here, because here we have a multiplication sign here. So let's equate this. So this now implies that our p is equal to 0, or our p minus 11 to the power of x is equal to 0. Okay, so we have two cases here now. So let's recall where we said let p be equal to this. So let's take our case 1. So from our case 1, let's take our case 1. So from case 1, we're going to have our p is equal to, we have 7 to the power of x minus 11 to the power of x. So we equate this to 0, right? So this now implies that our 7 to the power of x minus 11 to the power of x equal to 0. This is easy. So how do we do this? Move this to this side of the equation. To give us 7 to the power of x is equal to 11 to the power of x. Divide through by 11 to the power of x. Because we want to make the right hand side to be unity. So this to the power of x. This leaves. So here we're left with what? 1. It's easy, right? We can rewrite this side of the equation because we are having this to the power of x and this to the power of x. So this is going to give us here 7 all over 11 all to the power of x. This is equal to our 1. Yeah. Oh. So what do we do? We can take log to base 10, but here because of what we have here, I want to take log to base 7 all over 11. Okay, so let's continue. Side is going to give us here log our 7 all over 11 all to the power of x, then base 7 all over 11. Okay, this is equal to, this also will give us here log 1 base 7 all over 11. Okay, now here we apply the exponential law of logarithm again, whereby we move this to this side. So if we do that, this is going to give us our x times log our 7 all over 11, then the 7 all over 11, then everything equal to log 1 base 7 all over 11. Now, if we look at this carefully, we know that the log of any number base itself is equal to what? 1. Remember, we said that log a base a is equal to what? 1. We've established this fact already. And again, log our 1 base a is equal to 0, provided a is not equal to what? 0. We'll say this before now, right? So if we apply these two laws here, then automatically we're going to have this to be 1 and we're going to have this to be 0. So we're going to have this to be our x, they equal to 0. So this is the first root to our exponential equation, our math Olympiad problem. Okay, so let's go ahead and take our case 2. So we have here case 2. What is our case 2? Remember, our case 2 is p minus 11 to the power of x equal to 0. P is given, or we said let p be equal to 7 to the power of x minus 11 to the power of x. So let's replace it here. Okay, so this is going to give us here 7 to the power of x minus 11 to the power of x for p, and here we have minus 11 to the power of x already, so minus 11 to the power of x, everything equal to 0. So this minus this will give us 2, right? So this is going to give us 7 to the power of x minus 2 into our 11 to the power of x equal to 0. Again, we move this to the side of the equation, right? So this is going to give us 7 to the power of x is equal to 2 times 11 to the power of x. So what do we do at this point here now? It is easy. We divide by 11 to the power of x. So this will now be this all over this, and again we have this all over this. So this will leave the system. Then here we rewrite this to give us here 7 all over 11 all raised to the power of x equal to 2. Easy. Again, we take log to both side of the equation. Here we're going to take log to base 7 all over 11 again because of this. Okay, So if we do that, this is going to give us here the log of our 7 all over 11 all to the power of x, then base 7 all over 11, right? Then equal to our log 2, then base 7 all over 11. Okay. And again, we move this to this side. So the whole of this will give us our x will now be equal to log 2 base 7 all over 7. Sorry, all over 11, please. All over 11. We can simplify this applying the change of b's to this, right? Good. So remember, the law of change of base says that if you have log, let's take our a, the base b, and you want to change this base to c, this will give us here log a base c all over log b base c. Remember this law? Yes. So we can apply that to this side of our equation. So this is going to give us here our log 2. We want to change to base 10. So log 2 base 10 all over log 7 all over 11 base 10. Easy. Okay. So what we do here, we can apply the division law of logarithm to this base here. We say that if you have log m all over n, this is equal to log m, then minus, let's manage this space here, log n. Okay, so if we have this, let's rewrite this. So this will now give us here log about 2 base 10, right? All over log 7 base 10 minus log 11 base 10. Okay, so what is our x2 now? So let's write out our x2 very well. So therefore, let's manage the space here. So therefore, our x2 is equal to the log of 2 base 10 all over the log of 7 base 10 minus log 11 base 10. This is our S2. Okay, so you can get the numerical value by plugging this into your calculator, and when you do this, you get your numerical value. So this brings us to the end of this Math Olympiad challenge, which is this very question here. Okay, so we have been able to solve for 2 roots to this Math Olympiad challenge. If you learned something from this video tutorial, give the video a thumbs up. And if you have a question with regards to the approach I applied here, then drop it in the comment section. We are there to reply to all your comments. Thanks for being there. We all here love you dearly. Bye for now.